And good afternoon once again, ladies and gentlemen, on this beautiful Sunday afternoon outside of Atlanta in Chattahoochee Hills and on the beautiful Serenbe Farms. And I'm standing now with the winner of the 2019 Ray of Hope Prize. This is Tyler Mantell. How are you, Tyler?
Pretty good. Thanks, sir. Glad to be here. It's a cool event.
Well, let me tell you what. Winning the Ray of Hope Prize is no little thing. He's developed some technology. He's got 11 different patents, I believe, right now in the marketplace that is changing our ideas on how to sustain water for municipalities. And let's talk a little bit about that. How did this all get started for you?
Yeah, so the thing that people often don't know is that 20% of the clean water, the water that we clean for drinking water, never makes it to a home. So that means that there's 20% of the water we've gone through the effort of pumping and cleaning that gets lost to leaks in the infrastructure. And so for us, the problem gets to be what can people do for it? Because we get water shortages. You get water shortages, and one of the places we're doing some work, there's 1 billion cubic meters short every year. And in other places, what we represent is less the water shortage and more what it does to a city. I'm sure plenty of people around here have had the experience when you sit behind traffic because they've been trenching an entire street. We're trying to eliminate that. Our robot goes into a pipe, it finds a leak to 1 foot. Because you can find it to 1 foot, you can create where you're digging one hole. You're not trenching an entire street trying to locate something underground.
So the water leak disadvantage, you can rearrange and turn it into an advantage for an area municipality. And for anybody that's listening today or will see the video at some point in the future, you're sort of the go-to guy. You're in Boston, Massachusetts, and I know you circle the globe. And one of the pilot cities or cities that you're working with is San Antonio, Texas. And that was that the example that you were just citing where they're having the shortage? Or tell me about what their difficulties were.
No, so San Antonio they have some water shortage problems every once in a while, but in a place like San Antonio, it becomes a cost problem. You can always buy more water, whether it's water from other states. We're in North America, and we're fortunate enough to have enough water. So for San Antonio, we're a cost mitigation strategy. We can be more cost effective to repair and maintain infrastructure so that the water utility can grow without raising rates to all of the constituents and to the ratepayers.
Okay, so that's a more functional approach for North America, but now you're doing some really outstanding work, which was really the origination of the prize for you, and you're working in Vietnam, in Da Nang.
Yeah, so I have a project coming up that I'm working on with Da Nang's water utility. And in Da Nang, it's less about the infrastructure damage, and it's about trying to get water to their citizens. They run 1 billion cubic meters short every year, which means there's 1 billion cubic meters of water that's needed for basic human needs, whether that's washing yourself, drinking water, or just the basic things that you need every day. They're short 1 billion cubic meters. So we're going to go in and locate leaks so that they can fix them with some grant funding, and so they can come in and repair their infrastructure to get that 1 billion cubic meters back and give it to their constituents.
And unlike the United States or some of the more civilized nations that have water in more or less abundance, they can't go on the market and import water at all, can they?
No, they couldn't, because the places around them are in the same problem. So there's nowhere they could buy it from, and the infrastructure isn't present there to get water from one place to the other. And that's why that's really important to us. A lot of companies, when they start, look only to what they can do to generate quick cash. At the end of the day, we're instilling things like going to Vietnam early because it's important for what we can do. It's important for us, and that it's important for people like the Ray C. Anderson Foundation, and that's why they've given us this prize to help us move forward.
So as the CEO, founder of Watchtower Robotics, tell me about the design that allows you to zero in that technology and get it within a foot, as you say. What inspired you for the design?
Yeah, so the design was inspired by nature, actually. That's why the Biomimicry Institute's been a huge help for us. What we have is a robot that can swim through pipes. So we pump it into a fire hydrant. It goes around. The first problem you have is how do you get a device at all to get through the unknown nature of a water pipe? Underground, you have a bunch of assets that are bigger and smaller. You have obstructions, tuberculation, and you have to get through it all. We have a squishy, flexible robot, so it goes through. It looks a lot like an octopus in the way it can collapse and get through small obstructions. And then we feel the pipe wall. It's exactly the way that you would feel for a vacuum cleaner to see if the suction force is on. We look for that same suction force on the wall of the pipe to represent a leak. We took inspiration from a lot of other areas when we start to do things like loop closure on the way rats can navigate a maze is the same basis for how we can create an underground map of an asset without being able to see it or communicate real time.
Now, how do you directionally control that robot when it's in the system? Because I can imagine there are all kinds of tributaries and breaks that work off the main water system. How do you track it, and how do you make it go where you want it to go?
This is where the water utility is a really important part of this whole solution. They come in, and we are part of a process called pigging. You run pigging, right? Biomimicry, and it's. But we run our robot through the network in the same way you would clean the network. So if you think about controlling, there's all sorts of valves all over a city so you can isolate areas of the city. We leave them on, but we create a flow that goes in a single path. And so as we put our robot in, it'll follow the majority water flow. So as long as we've designed the network such that water will go in one direction, we know where the robot's going to be and it'll come out.
And so you talk to the any end of the groups that are going to direct that water, and you design a pattern, and that's how you follow through?
Yeah. So I was actually in front of a water utility director really early on in my water experience, and I told him I could put a leak on a map to 4 feet. And he looked me right in the eyes, and he asked whether I could tell him where his pipe was. And that blew my mind, because you have assets underground that have been there for 70 years. We went into the back room, and we looked at a map that he had, which had postcards all along it. And on these note cards were written pipe specs, the street it ran down, and he pulled one off and asked a question if I knew where something like the Granny Applesmith Road was. And I was like, no, but I assumed you guys did. And he said, yeah, we do too. We're pretty sure it's First Street, but we're not 100% sure. And even assuming it's First Street, they don't know whether it's on the north side of the street, the south side of the street, or on the center line. So we realized that one of the big things we can do is we can make it more effective, because today what they'll do is they'll dig up that entire area to find one leak. So now if we can put it on a map to 1 foot, they're digging up a hole, and they're fixing an exact location, and they're causing as little interference to the rest of the area as possible. And obviously it's more cost effective. Obviously it saves energy, and it obviously disrupts as little as possible for the environment, which includes the people and any animals that are living around there and nature.
So you describe the robot as being somewhat squishy and can adapt to its own environment, much like the invertebrates that are going in the ocean. So what is the largest size pipe that you can research, and what is the smallest size it can go to?
Yeah, so we inspect pipes that are anywhere between 3 and 12 inches. And the reason is because as we're squishy and we're flexible, those are the pipes that we can access through fire hydrants. So as we get more established, we'll go larger because we can do that. But our deployment methods will have to change because fire hydrants aren't attached to those. But right now, all the distribution mains, anything that runs through your neighborhood would come to the front of your property. That's the pipes that we inspect.
Now, the Ray of Hope is not the only prize that you've won recently. There's another big prize. Tell me about that.
I won a prize in Stockholm, Sweden, and actually it was for all the work we can do in places like Vietnam, where we can create a difference for people in urban environments. That was called the Urban Water Challenge, how we can bring more water to these urban places, because Vietnam is an example, but everyone knows about places like South Africa that have major water shortages. And so when you're losing water in places like that, it's really important. And so that came from Imagine H2O, the Blue Water Group, and the 11th Hour Project, who are doing a lot of work in this area, specifically in water.
Wow. Everybody, this is Tyler Mantell. He's with Watchtower Robotics. He's really on the cutting edge, and just when you think you knew everything about water and how to conserve it, there are still more ways, and he's helping to do that. One of the great things about the Ray C. Anderson Foundation Biomimicry Institute is we're looking for people just like Tyler. Maybe you're the next person that we're going to be talking to in the not too distant future, but everybody's welcome here. You have a great Ray Day. We'll be back with another interview in just a few moments.